I guess until now we done binary search, we are in binary search. I completed these two problems. So currently I am at B is the question. Previously I tried to solve it, but I didn't got idea, so I referred to the video solution. But why is why the function is going monotonically? I'll tell you exactly and right. So I thought it is not monotonic. But if you do assuming it as a monotonic, like first splitter, you have a splitter. A splitter can convert one output of water flow into this number of water flows. The splitter types are 2, 3, 4K. Suppose if you have two splitter and there is a water running, so if I attach that two splitter to this water source that running, so my final I will get two two output water flows. And suppose we are having currently four output water flows. Suppose assuming water is entering here, so four water flows are coming out. So if I attach another three splitter to here, then I will get three another, right? Three plus in this level only three available because this one is joined to below. So in this three and next three plus three six. Mm. First we will check the not possible case. How it is not possible. So you got it right. You have given input n and you have k outputs and already there is a one pipe with flowing water. Initially you are having one output source. So with using that one output source and you have splitters to use, using these splitters and that water source, can you make n outputs? N output? That is the question. First I will minus one case. So previously I assumed many wrong things. I overcomplicated. Mm. Okay. Mm. Not possible case. You have n equal to 4, 8, and k equal to k of 4 means that means you have 2, 3, 4 output. Splitters. So initially you have one. Now first, suppose at level 1 I attached the biggest splitter. So I attached 4 to 1 water source. Then my resulting output will become 4, right? 4. So split karo. 4, 1 plus 1 plus 1 plus 1. And again. And again at this level, use that last one for splitting again. Let's split this last one with using three splitter. Then it will become three. It will become three. That means one plus one. And let's again split this source using two splitter. Mm. So my splitters are completed. So how many outputs I'm getting? Three plus four, seven. So I want eight, but maximum I can get is seven because I can only use splitter eight at max one time. So for the man not getting condition, see, initially, mm, so initially I have one in one flow. Then after adding four output, I got four. Then after I'm adding the three splitter, then I'm getting three plus three. And here three plus two plus two. Like what's happening is if there are suppose X output flows. After adding any splitter, one will be overridden by the splitter. Suppose if I added a k splitter, this x will change to x minus 1 plus k. Hmm. That's happened here. So how to get maximum value? I'm going to use every splitter, right? So every splitter means I'm using k, 4, then 3 plus 3, then 3 plus 2. Observe the pattern, right? Here k minus 1, here k minus 2, until 1. And the last splitter we are added, 1 plus 1. In that, we don't have any decrement of a 1. So that's why I'm adding 1. Because last splitter water outputs will remain same because they are not going to affected by any other splitters which are going to add because there are no splitters the to add to it. So this means 1 plus 2 plus 3 up to k minus 1, right? And there is also one entering, I mean this one. Hmm. So let us assume this as sk or s of k minus 2, sum of first k minus 1 times plus 1, sk minus 1 plus 1. Hmm. The answer is not possible if sk minus 1 plus 1 maximum output that can be given less than required. This is the case answer number. So first of all, write the function of sum or not LL sum index, not index, LLX return x star x plus 1. Okay, I have a question for you. I mean, suppose if x is odd, then what is going to happen? X plus 1, let us suppose 3 plus 1. No, if x is even, x equal to 2, 2 plus 1, 3 by 2. 3 by 2 will 1, 1 into 3, 3. But actually it should come 3 into 4, 4 by 2, right? That means 6, but you are getting 3. Is it correct or should I add parentheses here and here? Is it correct? It is correct only because multiplication divisions are left to right preceding. So first multiplication will get done, then division. Mm, Now our S will be sum of first x times, sorry, not x, first k minus 1 plus 1. Hmm. If s less than number of required outputs, then yes, CO minus 1. Or if it is not the case, I'm going to apply binary search. Why it is, I mean, how can I apply binary search? Because it is showing exactly n pipes, right? First, I will make an argument. Uh, Minimum number of pipes, minimum number of splitters to make exactly n pipes equal to minimum number of splitters to make at least n pipes. So we obviously know, suppose if to make n pipes, at least n pipes, we required, let us suppose our n here is 3. So to make 3 outputs, we need some x number of splitters. I will ask the question, how many number of splitters will you need to make 2? the phone. Because, I mean, I'm going to prove like this can be binary searchable. Minimum number of splitters. Let's suppose some space like variables answer space. Minimum number of splitters can be 0, 1, 2, 3. At max k minus 1 because there are 2, 3, 4, 8. Max k minus 2. So if with 3 we can make at least um, if with 3 number of splitters if we can make at least n pipes, then obviously with 4 number of splitters, then with 4 number of splitters also I can make at least n pipes, right? So if 3 is the answer, I will check for the this 2. Can 2 will be answered or can 1 will be answered? I'm making a decision if 3 if the 3 splitters can be, I mean, if 3 splitters can make n pipes, n outputs, then obviously 4 will make, 5 will make, k minus 1 will also make, k minus 1 splitters also make. So I will check for 2. Can 2 will make? So I'm checking for minimum condition here. So I think you are okay with that. Hmm. Now, how to prove this argument? Minimum number of splitters to make exactly n pipes equal to minimum number of splitters to make at least n pipe. First of all, minimum, right? So let us take an example 4 and 3. Here n equal to 4, n equal to 4, 4 outputs needed, and we have 2, 3, I mean, 2 splitters of one 2 type and another is 3 type. We have initially one output as water source. Now, first I will come from greater than 1 plus, see, this one is already directly split into 3. So, is it 3 equal to 4? Not. So, then I will split this 1 plus 1. I am splitting this 3 into 1 plus 1, and the remaining one I will convert into 2 splitter. Is it making this 4? Yes. Suppose if I have for minimum number of splitters too, I should come from back. I mean, I will first take splitter which is having maximum number of outputs. Suppose my 5 and 7. First one, then I will take directly 7, 1 plus 6. Oh boy, it is greater than 5. How many splitters I use? One splitter. I will say this is the minimum. This is the answer to get n output also. But we are getting 7, right? How are you telling to get exactly 5 outputs also same answer? Because this is one way, or we can do like one splitter is directly converted into 5 splitter. So how many are getting? I only, right? I mean one only, right? 5 splitter. 5 splitter. How many splitters you use? One splitter. Here I am using 6. 6 splitter. Here I am using 7 splitter. Both are giving the same answer. Suppose if I used my n is changed to 9 or something, then first I will use 7 splitter. Okay, 7 output. Then 1 plus, I mean 6 plus, that 1 will be changed into 5, 12. 12 outputs are getting, but we only need 9. So, but until now, we use 2 splitters. I will say 2 splitter. 2 is our answer. But how are you saying? You should only produce exactly n pipes, right? But you are producing 12 outputs and you are saying minimum is 2. You will guess that is wrong. But see, 1 plus main splitter, right? Main splitter we can get by 7 plus 2. 1 plus 7. I mean 1 plus 6, 8. Then that one is 6 plus 3. Yes. So I am using 6 splitter. Sorry, not six splitter. Seven splitter plus three splitter. So please answer. So you will get exactly nine. As we are going, as we are only checking for minimum count, right? So this will also will give the same answer. I mean, what it is giving to 12 splitters, that will be same for exactly n also. I mean, here it are producing nine, it is producing 12. I mean, why it is coming same? Because here in this case we should use three instead of five, right? Yes, you can use so use nothing change. But if you can use five there, then you also can use three also there. So this case, these two are colliding. I mean, this is the reason why it is binary search work. Minimum number of splitters to make exact n pipes equal to the minimum number of splitters to make at least n pipes. So, and this resolved. Now we are going to binary search. LLO, my low can be zero. I mean, using zero splitters also we can do. And LLI equal to, I have, how many splitters I have? K minus one, right? Mm. If I want to check if zero number of splitters makes my answer. So if you're telling zero number of splitters, then first find the zero number of splitters from backwards. I mean, one number of splitter, K minus one. Two number of splitters, two number of splitters, K minus one, K minus two sum. I mean, we are adding descending order, right? Mm. So, what should I do? Yes, is the total sum. Mm, yes. Check for the lower boundary case. Found is zero. You will from zero. Okay. If I use mid number of splitters, that means this is the answer then, right? This number of splitters. Hmm. The capacity is 0.22, okay? But but if I use but if I use last splitter, then how many number of sound generated? One plus one plus k nineteen. If I use the last two splitters, then I'm generating one plus k minus one, k minus one. So you should write 1 plus 1, 2, 3, 4, 5 up to k minus 2. This one will be obviously there because initially one output though. Mhm. So if I use k number of splitters, last k number of splitters, I mean mid number of splitters, then what will be the answer? 1 plus. So mid, I'm using mid number of splitters. That means this is mid and these are k minus 1 minus mid, right? Hmm. So how do I get last mid number of sum? First total sum. Total sum means sum of this. Sum of that will be sum of how many tens in different total there are k minus 1 terms, but we don't want the last mid terms k minus 1 minus mid. Hmm. This will give first k minus 1 minus mid terms. Subtract this from total. Total means sum of k minus 1. So it should be greater than or equal to n. Condition. And we know 1 plus sum of k minus 1 is yes, directly. We already calculated it. Why should I do it? Greater than or equal to n. L answer equal to 0. If check not that right. Yes minus sum of k minus 1 minus m greater than or equal to n. And the answer one is equal to me. Then I will check for minimum number, right? So I will be mid minus 1. That means I can produce an output using mid number. So our constraint is to make minimum splitters, right? So mid, it is possible with mid. So I will check with lower bound, mid minus 1. So I'm updating here I equal to mid minus 1. Here log of it, lower equal to mid plus 1. P, here, and are you sure the answer is in 0 and k minus 1? Because they are giving k minus 1 splitters. Okay, yes. Huh? Dude, how did I get answer minus 1? Hmm. This video is